Okay, so in this section we're going to be looking at something called kinematics. Now, kinematics is all about using calculus for speed, for direction. It's about the rate of change of distance, really, in its essence. So kinematics, we've got three bits of information. We've got displacement. Now, for those who do physics, this will be nothing new. But for the rest of us, displacement is just a fancy word for distance. Now, it doesn't literally just mean distance, it's distance with direction. So, positive displacement would be direction in the front, negative displacement would be direction behind, going backwards. And we use a set letter for this, we use the letter S. And that's just a convention in maths, so we just always use S. And it's just basically just distance. Second thing we have is velocity. Now, velocity, this is basically speed with direction. Now, speed or velocity, we're going to use this letter V, so that makes a bit more sense. But speed, literally, the essence of speed, it is the rate of change of displacement. So we've done a bit of work with this rate of change. So we can see how with calculus we can connect velocity and displacement. And then we have a third one, we have acceleration. And for acceleration, we're going to use the letter A. And the acceleration is how fast you speed up or slow down. It is the rate of change of velocity. So acceleration, if it's positive, you're speeding up. If it's negative, you're slowing down. So these things all connect to do with rate of change. So if I have displacement, I can differentiate to find velocity. If I have velocity, I can differentiate to find acceleration, and vice versa. So if I have acceleration and I want velocity, I can anti-differentiate. Again, velocity back to displacement, anti-differentiate. So these things are all connected mathematically. So we're going to look at a problem now on slide. It's a slide about kinematics. So a body moves in a straight line. Its distance in meters from the origin. Now, origin just means the beginning in this sense, or it's the 0, 0 on the graph. So its distance from the origin is given by this fancy equation. T is in seconds, and we want the velocity. So example 1, if we have st, 10t squared minus 4t plus 8, remembering if we have displacement and we want velocity, we simply differentiate. So velocity, that's what we get if we differentiate t. And we've done this before, so 20t minus 4. And we want to know the velocity at the end of 5 seconds, so when t is 5. And 20 times 5 minus 4, that's going to be, let's be super sure, there we go, 96. And velocity is going to be, it will be in meters per second. Now, something to think about in kinematics is this notion of time and where we start. So we start at 0, and then 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. And they said at the end of 5 seconds. So that's 1, 2, 3, 4, 5. So the end of 5 seconds is literally when t is 5. If we said that there's like a classic question that says the difference between the fourth or in the 4th second, and that would be 1, 2, 3. The 4th second, how far it travels in the 4th second would be the difference between these two times. So you have to understand this concept of time and how it works.